All right, so now we're going to look at Rule 14-100, overcurrent protection of conductors. So the infamous top conductor rule. Let's take a look. We'll read it first here in the first video. We'll run through and then we're going to do some examples. I've got a couple examples written on the board here, and we're going to keep it simple. So for you students, first year guys, it's beyond your scope. Second year, third year, fourth year, definitely fourth year and third year. You have to know where top conductor rules are located, through whether it's a motor top conductor or just a general top conductor. All right, so let's understand what it says here. 14-100, overcurrent protection of conductors. Each ungrounded conductor shall be protected by an overcurrent device at the point where it receives its supply of current and at each point where the size of the conductor is decreased. So if we just stop there for a moment, and if we had to comply with that with no exceptions, and we do comply with that in our lighting panel. If you think it, here's our main switch. We have our main service conductors, 200 amps. They come in here on the load side of the fuses. We protect the conductors with the fuses. They come over, they feed the bus bar. So here the bus bar is rated for 200 amps. And we bring our branch circuit wiring in here. We mount the circuit breakers, and we comply with the rule. That's exactly what we do. And we're done, because it says right here, each ungrounded conductor shall be protected by an overcurrent device at the point where it receives its supply of current and at each point where the size of the conductor is decreased. So we bring in our smaller branch circuit conductors, put them in here, we put the circuit breakers on there, we comply with that statement, we're done. But then it goes, except that such protection shall be permitted in each of the following cases. So if we look here on my example, we have a 600 amp switch. I'm going to have 600 amp fuses in here, 600 amp conductors from the load side of the switch, and they're going in and they're going to feed the bus bars in the splitter. So we have 600 amp fuses and conductors feeding the splitter. And then I've got a 200 amp switch here and a 100 amp switch here. And if I had to comply with this rule, I'd have to put 600 amp wire into the line side of this disconnect here and the line side of this disconnect. So we have exceptions. So let's see what the rule says. The first one, A, is just a statement where it says, where the overcurrent device in a larger conductor properly protects the smaller conductor. So if we thought of that, if in table 14, it gives us a little leeway in having a fuse rated higher than the ampacity of the conductor. So as long as we complied with the rules and table 13, we could get away with it. So that's just kind of a statement rule. So it's really 14-100, B, and C. I'm just going to put them on the board here. These are the two that you have to understand. It's quite a long rule, but the basic part is B and C. And let's see what it says. B says, where the smaller conductor has an ampacity not less than the combined computed loads of the circuit supplied by the smaller conductor and not less than the ampere rating of the switchboard. So on my examples here, I have a 125 amp load, a 200 amp switch. So if I put in 125 amp fuses, so here, I've got the 125 amp load, the conductors in there without selecting them. It's just the number game here. You're trying to understand the rule. 125 amp load, the conductors must meet the requirements of the load. The fuse is going to protect these conductors. So the key here, what size of wire do I need? I'm tapping off my 600 amp splitter and I'm feeding the line side. So B says, has an ampacity not less than the combined computed loads of the circuit supplied by the smaller conductor and not less than the ampere rating of the switchboard, panel board, or control device supplied by the smaller conductor and is not more than 3 meters long. So here, my top conductor is not more than 3 meters long. I've got to meet the requirements of the load and not less than the ampere rating of the switchboard or panel board. Therefore, I need 200 amp conductors in there. So, remember, you always must meet the requirements of the load. That's the first thing. So the minimum you start with is 125 amps all the way up. Then it talks about not less than the rating of the control device, switchboard, panel board. So I'm going to read it again. You guys highlight this in your code book. Where the smaller conductor has an ampacity not less than the combined loads of the circuit supplied by the smaller conductor, not less than the ampere rating of the switchboard, panel board, or control device supplied by the smaller conductor, is not over 3 meters long, does not extend beyond the switchboard, panel board, or control device that it supplies, and enclosed in non-ventilated raceways, armor cabled, metal sheath cabled when not part of the wiring in the switchboard, panel board, or control device. Just remember, you guys, this is a control device. It's a manually operated control device, all right? That takes care of B. And in the next example, we'll do C, all right?